Hi, good morning. My name is Xinliang Liu. This presentation is for the data mining project. So this project is to study like credit card fraud detections, passenger certifications. So I retrieve those data from Kaggle, and we were using those data for data mining analysis. So the objective of this project is to using the data mining method we learned from the class. Also from the innovation class, we are going to start a business. So learning those methods is useful, I think especially for staff, because we need to apply those machine learning methodology to detect whether people are honest about their feeling. So the first data set we choose is passenger satisfactions. So in this data, we have a different columns, including age, genders, class, customer types. So we have a different column that represent the characteristic of the passenger. Also, we have a different columns that represent different service. Actually, there are more service on this screen, but we just list some of them. For example, they're like flight distance. If a flight distance is long, then passenger probably not feeling they don't have a like positive feeling. And other things like food and drink, and or the seat comfort or delay time. We will visualize those data later, and then when we going through all this the data set, we will go into the coding part, and you will see how we apply those data mining method to predict passenger certifications. So this is the box plot of the passenger certifications. The second data set, we're going to study the credit card fraud detections. This data set also very popular in the Kaggle. Instead of a time and amount of transactions, we have a V1 to V28, which represent is actually V1 to V28. It's a principal component of a hidden financial characteristic. The third data set is we use similar strategy to study the financial fraud detection. The difference between this data set and the second data set is this is generated by some algorithm, because most of the financial data is hard to get, and those data are very sensitive. And also the main difference from this data set to the second data set is that we can see that the columns are for example, all balance. It's the balance between before the transaction and the new balance after the transaction. So in another word, these columns are we know what this column means. Not like second data set V1 to V28. I couldn't find any information that what does V1 represent, V28 represents. So for this data set, we have a more strategy to approach in this problem. So we're going to the coding part. So we're using R for this project. So this project, we first have to load in the data. We have to load the libraries and load the data. The data is large So we're not going to load the data again because all the data is stored in the environment already. But we can see how big the data is. So there are around 284,000 data in around 31 columns. So we can go over the names. As we can see their age and lake room service, cleanness, arrival delay in minutes. We also changed the name of some of a column because I don't like the name. And this was changing some of the data to factors I already downloaded. And this part we're going to plot. It's a 2D part to see how people are because we have a two class, which is passenger who is certified and uncertified. So when we plot in this plot, we can see, for instance, in-flight entertainment and departure delay time. What's the relationship with these two columns and the passenger certifications? So we can see that the red one is the passenger who are not certified, and the green dot represent people who certified. So as we can see that if departure delay time is small, then people tend to certify with the service. We can also see that for example, the delay time and the certification relationship. Well, for this project, I personally do a lot of analyses and visualizations. But sure, for this presentation, we're going to skip those plotting. And then we're going to split the data into training and test data set. So 2/3 of the data is used for training. And the first data mining methodology we're going to apply is using SVM. So why do we using SVM? When we learn classification problem, I learned that the SVM is some of the best algorithm to classify objects. So in this case, we're going to classify whether passenger is satisfied or unsatisfied. And after we build in the SVM module, we're going to use the module to we fit in the test data into this module to see how it goes. So SVM, well, in the first stage, we're using the kernel linear to build in this module, and also we'll tune the SVM to see what the code is best to predict the modules. I know that, well, except for using linear kernel, I also using the radical kernels to see how it go and see how it perform. But so far, I see the linear kernel, the performance as sounded well. It's still like well predict the data. So the first part, we're going to use the linear kernel and see how it go. Because we already built this module already, the disadvantage of using SVM is it is very time consuming. So when I train this data, I using I think more than 6 hours to train the data. So for this presentation, I'm not going to train this data again, but we can show you how it predict the data. So I think we're not. I think we don't have a time to doing all this coding again. But anyway, after we creating the this test data, we can using this to do the predictions. And then in R they have a library that you can use to plot in the confusion matrix. Because I already doing this already, we can see that the accuracy can reach 84%, and the precision is 0.83, recall is 0.92. For the discertified and certifies. So in my opinion, the result is okay. It's not impressive, it's impressed, but it's okay. With the next part, we going over the radical linear kernel. Again, we will tune these modules to see how he perform, and then we using the codes that perform the best in our modules. So we can predict using this module to predict but first of all, I think I forgot to plot the label, but it's okay. So we were going back to the linear kernel and using those modules to predict the result. So this is our confusion matrix. And then for radical SVM modules, we can use this to predict the passenger certifications. It will take a while to predict, but it just shows how it goes, how it done, how it was done. Okay, then this our confusion matrix. We can also use in the library to build a confusion matrix, but I just want to show you what's a quick way to show the confusion matrix. So again, it's another linear modules. We're going to skip this. The next the data mining tool we're going to use is to using logistic regressions. In R, it's a built-in logistic regression function that we can use. For example, for this coding, we can see that we're using the median square error as a measure type, and also we're using binomial family. This represents the Lazio logistic regression. So after we apply this module to use this to predict our test data, we have to transform the data into certified or uncertified. well, in this case, if the data is 1, that represent the passenger is satisfied. If it is 0, mean dissatisfied or unsatisfied. So that's how I done the logistic regressions. We try, actually in this project, I try many logistic regressions to see how well we can achieve the F1 score. And the F1 score it's a good way to evaluate the O3 data, because some of the data are highly imbalanced. For example, for our second data set, the credit card fraud detections is highly imbalanced. So although we usually can reach like over 90% accuracy, but we have that high accuracy is because most of data are usually not fraud. But when it comes to fraud detection, we want to really see how well to predicting. When we present a fraud data, we can really confident saying, oh, this is fraud. I think I take too much time. I think I probably don't have much time to showing all those coding. I can just quickly browse in the coding and show you how it goes. For our second data set, we first I want to see like what's the correlation between our dependent variable and our independent variables. For our second data set, we have a column, the V1 to V28, because all those columns are anonymous, so we don't know what does that mean and what does that represent. Furthermore, this is all principal components. So when I train in those data, I found that the correlation between the independent variable and dependent variable are all very small. So I want to see, so I pick those variables that only have a high correlations. For example, the correlation over 0.3. And I transform those data into training and test data set. So after our training and data set is ready, we're using decision tree to classify all those data. Well, in R, they have a 2 decision tree that we can use. It's from different library that we can use that can build our decision tree for us. So the decision tree is like a decision flow. So in the root, in each tree node that represent, if we meet certain condition, it will go either way until you go into the end to show what classes it is, and then we fit in our test data to see whether it's fraud or it's not fraud. And also we can like plot in our ROC curve. I think I missed some of a variable. Anyway, we can plot our ROC curve to see how well. For example, the area under the ROC curve is 0.94. It's very high, but it's not very impressive because it's imbalanced data. Apart from decision tree, we're using KNN. So we apply KN to the second and third data set. So for KNN, I tried different number of K. So then I pick the performance that have the highest accuracy. So for example, if I using KN to train data with K equal 9, it probably will take a while to training those data set. Okay. And then this is the confusion matrix. And this is our ROC curve. As we can see, the ROC look very well. It's too good to be true. The problem of imbalanced data is we have to undersample the majority of the data. Because other way the results are all too good to be true. Like for example, the accuracy can reach like 0.999, which is almost 100%. It looked impressive, but from a data analysis point of view, it's just not satisfying. So for our third data set, we will follow the same procedures, but we will using the random forest algorithm to predict the fraud data. I think I run out of time. So overall, this is our project. I will put all the detail on our report, and thank you for your professors.